Hey guys, welcome to this live session on Amazon EC2 Open Masterclass. We're going to start soon here. So let's get started. Let me tell you something about myself. Guys, my name is Mahendra Pandey. I work as a freelance cloud solutions architect come trainer. Having more than 18 years of experience, I've been working with multiple technologies. Right now working as AWS authorized champion instructor and Google GCP authorized instructor. As far as this open masterclass is concerned, we are going to talk about Amazon EC2. So here is the agenda for the day. We'll start with introduction to Amazon EC2. Then we'll move on to and talk about EC2 instance types, how to launch and manage EC2 instances. We'll talk about security and networking. After that, we are going to move on and we'll talk about elastic load balancer and auto scaling, followed by storage and data management on EC2. And we'll try to finalize this open masterclass by talking about monitoring and optimization of EC2 instances. As you know, I've been doing this open masterclass since past 3 weeks, and we've done this 3 times. Those who have been watching are already aware that instead of going through PPT and slides, we use the blackboard to get the job done. So no more PPTs, no more death by slides. I'm going to move on and start talking about what exactly Amazon EC2 is. And let's log into the console simultaneously. Starting with the first thing is introduction to Amazon EC2. What exactly is Amazon EC2? Okay, if you can give me a minute here. Okay, so let's talk about Amazon EC2. Now, the moment we start talking about Amazon EC2, Elastic Compute Cloud, that's exactly the reason for why it is known as Amazon EC2. This is a service offered by Amazon that caters to the requirement wherein you may have a need for a virtual machine to be created, what we call in AWS's instance. So this service will let you create a virtual machine, and this is a part of the offering where we call it as infrastructure as a service. This is infrastructure as a service. Uh, just to let you know, the moment we talk about infrastructure as a service, the pricing model that we have is pay for what you reserve, not what you use. Pay for what you reserve is basically a concept wherein if you create a virtual machine and let's say a virtual machine is being used for only an hour or two, but you kept that virtual machine running for 24 hours, it does not matter how, uh, what kind of applications and how long an application has been running on virtual machine. But if you keep it on and if you keep it running, irrespective of whether it is being used or not, you will end up paying uh, for the duration that the virtual machine runs. So this is pay for what you reserve, not pay for what you use. Okay. So if it is a virtual machine, we'll talk about what types of virtual machines can be created, how do you select the operating system, and all those details by looking at the screen here. So you can go to EC2 by clicking on compute, since this is one of the compute services that AWS offers. Compute is something that will let you run your applications, right? Here it is EC2, or if you've already created the shortcut by making it favorite, you can click it from here and go to EC2 screen, or you can simply type in EC2 here. Click on that, and there it is. That's the dashboard. Now on this dashboard, you can go to instances. And from here, you can click on launch instance to basically create that virtual machine. Let me click on launch instance. So right now I'm just going to show you the page, how it looks like. This is where you can define the name of the virtual machine. Do note that the name of the virtual machine is not the host name, but rather just a name tag that is provided. And all these sections that you see, we are going to cover and touch upon all these. Let me define the name. Let's call it demo VM. Do note I'm using the term VM here, though in AWS we don't call it a VM, we call it an instance. Does that make any difference in the way how it works? Absolutely not. It's going to work as any other virtual machine that you might have used and worked with. The next part is where we talk about AMI, Amazon Machine Image. First question is, what are AMIs? Now, if you look at this, it says an AMI is a template that contains the software configuration that is basically your operating system. Which is basically required to launch your instance or launch your virtual machine. So it's a template of the operating system. You do not have to waste time in installing the operating system once you create a virtual machine in here in AWS, right? You can choose from these pre-installed operating systems, and these are just going to be copied onto the storage that you define, the type of storage, and there you'll have your virtual machine running, ready for the usage. These are all the selections of the operating systems offered by AWS. If you want to search for more, you can click on browse more AMIs, and you can do that from here. These are AMIs which are offered by AWS, but you can create your own AMIs if needed. I'll show you the procedure how. Right now, let's focus on just AMIs right now. So let me select Amazon Linux. And from here, you'll get a selection for what version do you want to use. For example, if I select Ubuntu, then we have all the versions. So I'm going to make the selection here. I'll keep it Amazon Linux. Next part is, this is where we choose the instance type. Now, instance type has this naming convention. Let's break it down, try and understand. You see here it says T2 dot micro. Now T represents family, 2 here represents generation number for that family, and this part here represents the size. Right sizing your virtual machine is important if you don't want to waste money, right? You don't want to create a virtual machine where the resources are underutilized, because as said, this is pay for what you reserve. So if you're creating a virtual machine that has say 64 GB RAM, but you were able to use not more than 12 or 15 GB of RAM for that virtual machine, it's not that you can go back and ask AWS for any kind of discount, since you did not use the other remaining 10 or 15 GB of RAM or resources. In that case, RAM was just an example that I've taken. If that happens, you will end up paying for what you reserve, right? For the entire day, if you have not run anything onto it and the virtual machine keeps running, you'll end up paying here. Now, as you can see, here it says free tier eligible. A free tier does not mean that everything is going to be free. If I click on drop down, you can see that in T2 family, we have T2 micro that is free tier eligible. And if you go and read about this in the documentation, it says that 750 hours of a free tier eligible virtual machine can run in the entire month without costing you any money. So that's free tier eligible. If it goes anything beyond that, you'll have to pay for the same. So for this demo, I am good with T2.micro. Now there are others. T basically is a family that represents general purpose usage. So if you have any kind of application that may not be very compute intensive or memory intensive or IO intensive, you can go for this T family. And if you try to read about it, you'll find more. So AWS EC2 family. Let's look at some of the images. So if you look at this, you'll find it shows that family that starts with T or M. T for tiny or turbo, as it says. M is for main or happy medium. Now these two families are good for general purpose usage. If you have any kind of application that happens to be compute intensive, you can go for C family. Same way, if you have an application that is memory intensive, you can go with R and X family. Now, when we talk about C family here, let me give you an example. Let's say you're trying to work with some kind of an application that does some fluid dynamics or very compute intensive kind of work, right? You may want more amount of CPU than the RAM that is needed for the app. This is where I'm going to choose compute optimized. Or maybe if I'm trying to install and use SAP HANA, which happens to be a in-memory database. So I'm pretty sure, since it is going to be an in-memory database, it's going to use a lot of RAM. If I'm looking for something with GPU, I can go with P family. Storage optimized, we have H, I, and D. Right. So if I go back here, and drop down, let's say if I need M1, so here it is, starts with M1. Or maybe I'm looking for something that is compute optimized, C4. So all these are families, and the generation number that I'm typing here, see, if I type C4, you'll find C4.large. If I type C5, there also happens to be a generation number that is C4 and C5. Now, Mahendra, what difference does it make? Because as far as sizing is concerned, I can see both the virtual machines are going to have the same size, that is 2 CPU and 4 GB RAM. So if I say C4 dot large and C5 dot large, sorry, C5 dot large, what's the difference between these two? The generation number represents a newer generation. Statement that can do justice for this generation number is, you'll find that higher the generation number, better the price to performance ratio is going to be. You try to run the same workload, and this is not an exact pricing that I'm talking about, but if you try to run the same workload on C4.large, let's say I'm trying to run some database on C4.large, exactly the same size, a database of 500 GB, right? With 2 CPU, 4 GB RAM, that is the same size, but in C4, let's say it's costing me some $55 a month. You may find that if you move to a newer generation, the same workload may cost you, say, $45. The performance remains the same, but the price has gone down here. So most of the time you'll find that moving your workload from older generation to a newer one will give you a better price to performance ratio. Now for this demo, as I said, I'm going to keep it T2 micro. And this part where we say micro here, you can see micro here defines the size of the virtual machine. 1 vCPU, 1 GB memory, right? 1 vCPU, you can consider a virtual CPU as a core being provided to a VM, right? Same way, if you look at T2.small, with T2.small, you'll find that it has same CPU, but the memory size has doubled. T2.medium is 2 vCPUs, 4 GB RAM, and so on. So we have large, X large, 2X large. Some of the other families that you go to, you may find 2X or 4X large, right? So that will define the size of the virtual machine. As for this demo, the size that I'm looking at works good for me. So I'm not going to make any change here. Now, once you create a virtual machine, how do you log into a virtual machine? In none of these configurations, you'll find that it won't ask you for any username or password for the virtual machine. So you will have to create a key pair. As the name implies, key pair. That means it is an asymmetric key. We have two keys which are created, a private key and a public key. You can click on create new key pair. Here it is. And you can define a name. Let's say that's my key pair name. And as soon as I click on create key pair, when prompted, store the private key in a secure and accessible location on your computer. What this says and what is going to happen is this. So as soon as we say create a key pair, it's going to create a public key and a private key. Now this private key that you're looking at is downloaded on your machine wherever you're going to click on create key pair. So if I click on create key pair, it's going to download on my machine this private key. And the public key will be associated with the virtual machine that I'm creating. So the VM that I'm creating here, public key gets associated with that. So with the help of this public and private key, we authenticate. It's kind of a password-less authentication. You just have to maintain the private key, and it's important that you focus on the security. Make sure that it's secure and accessible only to people, those whom you want that they should be able to access this virtual machine, right? Principle of least privilege says everything is implicitly or should be implicitly denied unless and until explicitly allowed. So same principle applies for this as well. If you're keeping your private key, make sure that only the people, those who must use the virtual machine, have access to the private key. Now, once I've created the key pair, I'll be able to log into the virtual machine. The security implication of this key pair is going to be, if you lose this private key to anyone else in the world, he or she, having details about your virtual machine, will be able to log into the virtual machine. Is there a way how you can make it secure? Mahinder, is there a way how I do not create a private key and still have access to the virtual machine? Yes, we do. We are going to talk about it in security section. So for the demo, I've already created the key and I've kept it. Just to let you know. Let's check out. I'm not having the key, probably deleted, not a problem. We'll try to create this in another region. Yeah, the virtual machines are also region specific. So you've seen that I was in Singapore. I've changed it to North Virginia because I have all the keys available for North Virginia with me right now. I'm sorry for this. I'll have to redo. So demo instance, keeping it Amazon Linux. T2 micro as instance type works good for me. And I want to use this key. For the record, I do have the same key available with me over here. Sorry, it's root lab demo. And I will need this key every time I'm going to log into the virtual machine to do any kind of configuration work, or maybe installing the operating system, installing the application, or installing the operating system patches. Gonna show you the demo for that as well. Now here is the networking section. Last open masterclass was on VPC. So those who were not able to attend the previous masterclass can go back and have a look at it before you come to EC2, because that has all the information that you may need to understand what exactly is it talking about as far as VPC, subnet, public and private IPs are concerned. I have two VPCs, but I'm going to keep it default VPC. The subnet that I want to select is this subnet, which has a CIDR range of 172.32.0/20. Since I'm selecting this subnet, you may also observe that it's going to be created in availability zone US East 1A. So the private IP that the virtual machine gets is going to be from this CIDR range. Auto assign public IP. A very important part to note is, going back to the screen here, a very important part that I wanted you to note apart from this public and private keys. Right now, I'm working on my machine and I happen to be in Bangalore today. Uh, so from Bangalore, if I want to access the virtual machine that is right now being created in North Virginia, I will need access to the internet, right? I do have access to the internet, but just having access to the internet is not enough. I also need to have a public IP associated with the virtual machine to be able to access it, because the private IP that we are looking at, this private IP is for private usage only. It's only going to work for LAN, local area network. It's not going to be working on public platforms like internet. So for that we need public IP, and courtesy of AWS we do get public IP, though rotating one by default. Rotating is the public IP changes every time you stop the virtual machine and start again, but that gets your job done, because this public IP that you'll be looking at will let you log in into the virtual machine, install application and patches and do work with it. So I'm going to keep it enabled. Next is, again, those who feel like this happens to, or this seems like a foreign land, you may want to go back and look at the previous masterclass. So security group is kind of firewall, a firewall that is going to protect the perimeter of the entire virtual machine here that I'm creating, this virtual machine. I have already created the firewall demo SG. Let me show that to you. If I can go back to VPC. Here is my list of security groups, and I'm using demo SG for this. So let me show you demo SG. If you look at this, by default, none of these inbound rules are created. So by default, the firewall does not permit any kind of traffic into the virtual machine. Okay, so I've created these rules, and one of the rules says that I want to accept incoming connection for SSH from anywhere. And that's exactly what I'm going to use this security group for. Next is configure storage. Now, this is a disk which is going to contain the copy of the operating system we chose in AMI. AMI happens to be a pre-installed image of the operating system. It's a template. So this gets copied as it is, as said, pre-installed. So this gets copied as it is. And this is known as your root disk. The root disk is the one that contains your operating system, right? Here it defines minimum. So I do not want to change it any less than 8 GB that it says here, though you can make the value higher, like you can keep it as 10 GB, 20 GB, right? So let me create the root disk of 20 GB. You may not want to make any changes here. I mean, it's not necessary that you have to. You can keep it to the default as 8 GB. Now, if you want to add an additional volume for keeping your data, your application data, you may want to click on add a new volume. Now, this add a new volume is not going to be a root disk. The first volume that you see here is going to be a root disk. This can be attached to the virtual machine. You can create a partition on this. You can create file system, mount it, use it the way you want, right? You can remove this. As you can see, the button for here is disabled. I can't remove a root disk, because if you don't have at least one disk, how are you going to have, or where are you going to place your OS image? So that's necessary. Keeping it simple, not making any changes. We are not going to create a volume right now, because I'm going to talk about this portion here soon. What difference does it make? Choosing the type of disk. So let's keep it simple. Configure storage. And that's it. Then there are other advanced details that we are going to leave for time being. We may come back to some of these a little later. So advanced details, we are going to keep it as it is. That's it. This is very quick how you can get started with creating a virtual machine. So let me go ahead and click on launch instance. And clicking on instances. Okay, we already have one running here. Let me stop this. And since I've been using this name, it's better I change the name here. Why not call it Open Masterclass Demo VM? Yes, you can change the name here. And this name that you're looking at happens to be a reserved tag, right? Any kind of resource in AWS, you can provide it a tag. A tag happens to be a key value pair. And this helps with searching. If you have a higher density of virtual machines, if you've got like 200 or 500 virtual machines, and you're looking for virtual machines which are having a tag of component front end, that means these are the virtual machines which are running front end applications. You can create here, you can add more tags. Name happens to be a reserved tag, and it's not reserved, I mean, it basically shows up over here. So whatever name you provide, it's going to show up as a name. You can add 49 more tags to this. A total of 50 tags per resource is available. The tag can be as simple as just A is equal to B. Right? As I said, it's a key value pair. So let's say component, this happens to be running a component of front end. And then here you can define environment, let's say dev environment. So I thought, like, while the virtual machine is coming up, we'll cover this very easy part. Now this makes my life a little easier. I can go back here and I can say that I want to search for a virtual machine which has a tag of A is equal to B. So that it says this is the virtual machine that has a tag of A is equal to B. Right? Or maybe component. And it shows up right away. Component equals, not equals, contains, does not contain. So component equals front end. Out of both virtual machines, only one. This one has component is equal to front end. So with searching, this makes a lot more easier for you to search and aggregate what resources are running with respect to a particular application, environment. Okay, so while I can see that my virtual machine is up and running, I can select the virtual machine. Let's log into the virtual machine to start using it. Now I can log in by selecting the virtual machine and clicking on connect. And for connection, as you can see, we have EC2 Instance Connect, Session Manager, SSH Client, and EC2 Serial Console. These are the 4 ways how you can connect to a virtual machine. Now, EC2 Serial Consoles are not available for all types of instances. They are built for AWS Nitro system. So there are some instances or instance type that you select which will enable, and you'll be able to have a kind of COM or serial connection to the virtual machine from here itself. For this demo, keeping it simple, let's click on SSH, and I'm simply going to click on the string here to copy this. I have internet connection and I have the key that I had downloaded when I was creating a key pair. So let's work with this. I just pasted the same string here. Hit enter. Are you sure you want to continue connecting? Yes. And voila, we are into the virtual machine, into the operating system here. So whatever you see from here on, this is all happening in the virtual machine that we have created here. You may feel like that this is the same, uh, even though this is the same terminal, but this is basically EC2 I'm using, and my local terminal looks like this. This is my local terminal. Right now, I'm connected using SSH into the virtual machine. Now, what else can you do? Yep, this is a VM. So, and let me tell you that Amazon Linux that we are using here happens to be CentOS compatible or maybe Red Hat compatible. So you can use the same yum update, yum upgrade command if that works. So everything that you would do into a virtual machine installed either on VMware or a virtual machine that is running on your laptop itself, you can do all of that from a virtual machine or instance offered by EC2. Now, this is a way how you will connect to it for Unix-based or Linux-based virtual machines. Very quickly for the demo, and I'm saying quickly because I wanted to show you later. I'm going to get into the details of each of these and going to explain you in a little kind of a depth here. But for right now, let's go for another virtual machine and let's create a Windows virtual machine and see what's the difference. Because for Unix virtual machines, we use SSH. For Windows, we use RDP. So is it going to be a little different for how do we connect and use it? Let's go for that. So give it a name, Windows VM. Here you can select Windows, what Windows version you're looking at. So I'm good with 2025 base. And then for this, let me select a virtual machine that's a little different than the previous one. Maybe I want to go with T3 dot large with 2 CPU and 8 GB RAM. Let's select this. Again, for Windows as well, it's asking me for key pair. I'm going to select the same key pair, and the key pair concept remains the same even for Windows, right? You're going to use a private key, and this time the private key is not going to be used as it is. There's a little bit of difference here. You'll use the private key to basically generate a password and use that password for logging in. So this key pair used to be used for logging in into the Windows VM. Keeping it same, but this time I want to create it in B, availability zone B. And that's the CIDR range. So my operating system, my VM that I'm going to create, the Windows VM, will bear the private IP of 172.31.0.x, whatever number it gets, because this is provided through DHCP, unless and until you want to go ahead and manually define. So if you do not, it's going to pick it up from the DHCP server of the VPC meant for this subnet. So that's the subnet. Auto assign public IP, I'll keep it enabled because I want to log into the VM. For security group, we'll use the same demo SG. And if I show you demo SG again, demo SG happens to have a rule for RDP again, accept incoming connection from anywhere. Is this good? If you ask me as a security person, this is not recommended. You do not want to accept incoming connection from anywhere. This is just for demo purposes, so hence I've kept it here. You need to specify the IP block or the exact IP from where you want the RDP to happen, so that everyone else around the world does not have access to the RDP to this machine. So let's move on and create this demo SG. That's my network settings. Configure storage, I'll keep it default. I don't want to make any changes here. So that's it. And we'll click on launch instance. There. So we'll just wait for this Windows VM to come up. Now here you can see the private IP of the VM. It's from the CIDR range that we have selected, 172.31.0.112, again offered by DHCP. And this is the public IP courtesy of AWS. As I said, this is going to be the IP address that's going to keep changing. Every time we stop the virtual machine, we start again, we get a different IP address for this. And this is purely meant for management purposes. Those who are looking for, if we can make this public IP a fixed one, then you're looking at not the public IP, but then you're looking at elastic IP address concept. Elastic IPs are public IPs, but they are constant. They are fixed. They don't change, right? We'll hold on to this part. Let's go ahead and let's try to log into this Windows VM. This is ready, I suppose. Again, we click on connect. Now you can see there is a difference. For when I have selected Windows, it's not showing me SSH as the default protocol for connection. Rather, it's showing me RDP client. Let me click on download remote desktop file. And here I have remote desktop file being downloaded. This file has all the details, including your public IPs and everything else that you'll need except for the username and password, right? So let me click on this. And this opens up Microsoft Remote Desktop. Here I have username, password. I haven't yet entered. We'll have to get password. So let me click on get password. And to get the password, you'll have to upload the private key file, right? And let me do that. That's the password that I'm using for this. It's okay. Mahinder, you just spoke about security and your password shows up on the screen. What is this? That's fine, guys. I'm going to delete the virtual machine as soon as I'm done with this demo. So as soon as I enter the password, that is being shown over here. I can copy this password, and this won't be visible unless and until you upload the private key file. And voila, I am into my virtual machine already. Since this is a Windows VM starting for the first time, you may have to wait for it. So it's not yet ready. I can't see the Explorer coming up anyway. Yeah, there you go. As said, first time, be a little patient. Yeah, there it is. You have your Windows virtual machine that's running. And as said, Windows VM, right? You can install your applications. You can use it exactly the same way as any other kind of Windows machine that you would use. So that's how you create Unix and Windows kind of virtual machine. Do we have any more? Yes, we do. As you can see in the AMI, we do have Mac, Ubuntu, we have SUSE Linux, Debian, Red Hat, all the major operating systems or all the major platforms that you may use to run your application is all available here. Now, before I moved on and I created virtual machine, I told you that these are the operating systems which are provided by AWS. Is there a way how you can customize and have your own Amazon machine image? Yes, we can, right? To do that, you will have to select the instance, let's say this instance, go to action, image and templates, and create image. Now this is going to create a template of your running virtual machine. A template, that means it's going to create an Amazon machine image. When and how do we use it? Why do you use it? Why do you want to create additional? Now imagine a scenario where you have tens of applications being installed in Windows virtual machine. I've spent some time, right? I've spent like say 2 hours or 3 hours of my time in a day to create a perfect VM for my open masterclass or maybe for some other purposes that I'm using it. I've already invested time, and if I have to redo this, I'll be wasting the same amount of time again. If you want to repeat creating the same kind of virtual machine, as in the Windows VM that has all the 10 applications pre-installed, right? If you want that kind of thing, you may want to create a Windows VM, install all your applications, configure the virtual machine, and then click on Action, Image, and Create Image. The moment you create image, you'll find all your images in AMI, that is Amazon machine image, which is owned by me. It starts showing up over here, right? What is the use case for that? Use case is, as I said, if you want to repeat and create multiple virtual machines, Windows VM, in other regions, or maybe the one Windows virtual machine that you are using happens to fail. I mean, the application it just got stuck or there's some problem. You do not want to waste time in troubleshooting here. Since these virtual machines that we are looking at, we consider them disposable resources, right? So instead of wasting time, I may spin up a new virtual machine with a pre-created AMI that I already have. I'm not going to waste any more time installing the 10 applications on it because I've already done that. And this new template that I've created for myself already contains all the applications in place. So I may just fire up the virtual machine and start using it rather than wasting my time in troubleshooting. for why the application failed. But of course, we may do that, but that's going to be the RCA that happens later. Now, okay, this looks good. I mean, Mahinder, you can create your own AMI and use that AMI to launch your instances. But what if in case I want to keep making changes in the AMI, right? This is Windows. And if I'm creating the AMI image of this Windows VM, it will contain all the Windows updates for up until today, right? For what if in case my company has a policy that we need to have the template or AMI updated um, every alternate day or every week, right? Every week is still manageable, but if it happens to be every day or every alternate day, then you are onto a repetitive task of creating a new latest Windows virtual machine, updating the patches on that Windows virtual machine, installing all those 10 applications again and again and again, right? Well, if you're doing that, use what is known as EC2 Image Builder. This automates the process of creating AMI image by defining conditions and criterias. So the private AMI image that I had created, I can create an image pipeline. And in the image pipeline, I can define a schedule that this image pipeline runs every alternate day, performs Windows updates on the previous AMI that I might have created and kept. And that way, every alternate day, without doing it manually, you'll have the same 10 application AMI image with latest Windows updates, right? This provides you the automation that is needed for creating the AMI image through the pipeline. So that's about Amazon Machine Image. Is there a way how we can upload our own VHD and other files? And this is a question that I was asked in one of the classes or trainings that I was conducting. So yes, if you do have VMware VMDX file, VMDX, sorry, VMDK file to AWS AMI, it's doable, right? You can do the import. So you can use VM import export to import virtual machine images from your virtualization environment to Amazon EC2 as an AMI. Okay, moving on to the next part. We've already spoken about instance type, so that's done. Instance type also dictates what kind of prices you're going to pay for the virtual machine. So you need to pay attention to this, where it says on-demand Windows base pricing is $0.0162 per hour. SUSE, we have Linux base. Then you have for Ubuntu and RHEL. This is the pricing for T2.micro. If you make a change here, if I click on drop down and I try to scroll through, maybe 2x large, the price changes. Now, those of you who are concerned about how do I know about an estimated cost for running virtual machines, there is a tool available and it's calculator.aws. As you can see, it says AWS pricing calculator. I can click on create estimate, search for all service, search for location type. I mean, I want to search for how much it is going to cost me running the virtual machine in North Virginia region. and that's just for EC2 that I want to do. So I can select EC2, click on configure. You have to fill in details. I'm going to keep it simple. It's a Windows virtual machine that I want to run. Windows server. Is it going to be a constant usage? Do you have daily spike traffic, weekly? And how many virtual machines are you looking at? Maybe I want to run 3 virtual machines. Then we have to define the instance family that you're going to use for this. Let's say C5N. How many CPUs? I want to use 4 CPUs, 8 GB RAM, and a minimum of up to 5 gigabit of network, right? So that's the family that I've chosen, and here I'm asking it to select the sizing based on the specification rather than the exact size, that is nano, micro, medium, large, 2x large. And it has started showing me all the selections that I have available for the purposes. Let me select this. Payment options, I'm going to talk about the cost part a little later for when we do the optimization. For right now, I'm going to keep it on demand. That happens to be one of the most expensive one, but at the same time offers you maximum flexibility, wherein you can start or stop the virtual machine at any point of time that you feel like, right? There is no commitment from your side to AWS for it. There you go. So that's it. As you can see, it says total monthly cost is 876 US dollars. If I say save and view summary, it shows up monthly cost, and here you end up seeing the cost for the entire year. Those of you who are wondering, is it including the cost for the Windows license? Yes, it does. So that's a great thing. Instead of going for a perpetual license and paying for it, you may opt for this. So that's how you can provide an estimate for, and that's just an estimate, guys. As I said, it may be a little higher than that or lower than that, but that's kind of estimate that you can provide to your customer. We've already seen how to launch. Now let me show you how to manage these instances. And some of the proof of concept that I wanted to let you know about, say this public IP, as you can see, and the private IP part. As I said, the private IP and the public IP are both automatically allocated. Public IP, we do not have any control. Courtesy of AWS, you may get any kind of public IP, right? Private IP address is under our control. We can decide what private IP address we can provide. If you do not, it's going to by default take it from DHCP. So for right now, let's see how to manage the virtual machine. How do I stop this VM? Now you can stop the virtual machine using your traditional Windows or Linux start or shutdown, right? It works. Or if you want to do that from management console, you can select the Windows virtual machine, click on instance state, and you can specify the state as stop instance. This will stop the instance, and as soon as you start it again, maybe today or tomorrow, it will pick it up from exactly where you left off. Now, does that mean that it's going to pause the virtual machine? It's not going to pause it, guys. Whatever applications were running in Windows virtual machine, they're going to stop. So once you boot it again, you start it again, you may have to start the application back again. So that's how you click stop the virtual machine. Another question from people, Mahendra, we have seen that even if the virtual machine was stopped, I was still having invoices from AWS that said that I'll have to pay for EC2 instance. So guys, you definitely have to pay for the EC2 instance if you've stopped it, but you're not paying for the CPU and RAM. That's already taken away. If you've stopped the virtual machine, there is no CPU usage. There is no RAM that is being utilized, but for sure, you are using the elastic block store volume. That means the root volume that you had created for keeping or running the operating system, it's still there, and you'll have to pay for this. So you're not paying for the virtual machine when the VM is stopped. You're not paying for CPU and RAM, but you are definitely paying for the volume, the root volume that is attached, still attached to the VM. So state here says stopped. As you can see, when I've stopped, the public IPv4 does not show up. It's gone. If I want to start again, I can click on Start Instance. And there it is, up and running again. This is to stop and start. But what if in case I want to completely delete the virtual machine? Well, in that case, you select the VM and click on terminate or delete instance. Now this will still ask you for whether do you want to really delete it. This is a deliberate action. Are you sure you want to delete? If you click on delete, it's deleted. And now I realize that I made a mistake. Oh no, I don't want to delete this. Now there's nothing that you can do about it. It has already sent an API call to delete the VM, and it will delete it. All the data that you had kept and everything is going to be wiped away, right? But Mahinder, what if in case it was a mistake? I didn't realize that I was looking at the same virtual machine and I just clicked on delete because I was in a hurry. How do you prevent this? Well, if the virtual machine is running mission critical application, you do not want it to be deleted in any condition. You can enable a flag, selecting a virtual machine, clicking on action, instance setting. There's something called as change termination protection. If you enable this and save it, now as many times as you try to terminate the virtual machine, it's just gonna fail to terminate this instance because it has disable API termination turned on, right? Modify the setting, change the attribute, and then try again, right? As I said, I could keep trying deleting the instance, but it will never. So this way you can provide a protection that, as in, there are questions from people that what if in case I delete it by mistake? You won't be able to if you enable this setting, right? I want to, so let me change and there are other things as well with this, which you can have a look. So we'll move on to the next part. What I've covered out of all this is we've already covered introduction, which was very simple. Amazon EC2 happens to be a service that lets you create a virtual machine, infrastructure as a service that lets you create a virtual machine in Amazon using Elastic Compute Cloud, and you can use it exactly the same way as any other kind of machine or VM that you may have used before, right? different instance types and sizes. We've seen how to launch and manage EC2 instances. Manage is how do you log in? I've shown you one way. Let me also show you other ways of connecting to your VM. Now, other ways of connecting is you need to have something called as system AWS Systems Manager configured for this. This is another service. In very short, AWS Systems Manager happens to be a service that lets you manage an entire fleet of virtual machines that you may have, and it lets you do every kind of automated task that you may want to achieve with your fleet. Say, for example, I want to patch I want to patch thousands of virtual machines, which are kind of mix of Windows, Linux, and in Linux as well, it is different distributions, right? We have Red Hat and Amazon Linux that follows Yum for update. We have Debian Linux and Ubuntu, which is based on Debian, that follows apt install, right? So many heterogeneous environments here to to patch, and it can do that automatically on thousands of virtual machines simultaneously for you if you may configure this. Right? You'll have to configure AWS Systems Manager. It does not work by default. Since this is out of scope of this class, I may not be able to cover on. But if you do, and once it is configured, you can use Session Manager to log in into your virtual machine, irrespective of SSH, RDP, to log in through the session. So start Session Manager. Now, if you've configured, let me see if I have it configured already. I may want to attach a role to this VM. So as I said, there is some degree of configuration that is needed, but once done, you'll be able to easily connect to your virtual machines without having to maintain any kind of private key, which again becomes an additional overhead if I create a private key that is a key pair and use that for logging in, right? Let me check on to Systems Manager if I can. And it's taking this because I do have an organization enabled. Since I had organization enabled, it was showing me all those things. Now, if you do not, in this case, I just deleted that. And clicking on enable the new experience, you can see it says we are configuring IAM role needed to power this configuration update. That's exactly what I was searching for when I selected on this VM and went to security and modify IAM role. So it's going to soon create that role automatically that I'll be able to attach, and then I can show you how you can use it for various other purposes, including session manager. So I'm just waiting for this enable the new experience that to complete creation of IAM role. This can take extended amount of time. Okay, no, sorry, we don't have extended amount of time. We can move on, and let me go back and see if this is really done. No, not yet. So let this run. I'll come back and show you how Session Manager looks like for Windows and for Linux machines through the Session Manager. But then apart from that, other ways to connect for Windows, we just have three here. We have Session Manager, RDP client, and EC2 Serial Console. For Linux VM though, this is a Linux VM that I had created before. For Linux VM, I can select we have EC2 Instance Connect. Right? This is kind of SSH client that is built into your built into this web page itself. Right? You don't need to have putty or some kind of terminal to do that job. You can for the virtual machine, provided that virtual machine has all the settings done in security group to permit the connection SSH from anywhere. Session manager, I'm going to show you. If you can give me some time. Right now, it's just working on it. SSH client, we've already seen. EC2 serial console is not available with all the types of instances. It's only available with some of the types. Basically, the ones which are supporting AWS Nitro systems. Let's check out on EC2 Instance Connect how it looks like. So if I click on Connect here, this is also a good feature that will let me in without having to manage any kind of private key for the virtual machine. There it is, logged in. Perfect. So those are various ways how you can connect and manage it. Launching, managing, and there are some more things that I wanted to talk about managing an EC2 instance. We missed on to two important parts that I wanted to talk about. One is the user data, and second is uh, EC2 instance metadata. So let's see what this is. Let me launch one more instance for the demo. Let's call it VM1. I'm going to keep everything default except for selecting the key pair. Rest everything else is default, so that is Amazon Linux. I want to bring to your attention the advanced details that it shows up. So for this virtual machine, I'm going into advanced details. The first thing that I wanted to talk about and show you is user data. User data is a script. In case of Unix, it's going to be a shell script. In case of Windows, it's a PowerShell script. Now, whatever you write as part of the script here will automatically take effect as soon as the virtual machine is created, so that you don't have to log in into the virtual machine for the very first time it's getting created, and you can provide an automation script that can configure the VM and bring it to the level that you want. For example, as soon as this virtual machine is created, and instead of giving it a name called VM1, let's give it a name called uh, web server. Yeah, let's install a web server in this. I'm not going to choose a file, though I have it written. I'm just going to copy paste the script here. Writing it again is going to be a waste of time. So that's my script. Now, those of you who are well versed with Linux, or you have worked extensively with the shell scripting part, would understand this without any effort. But those of you who have no idea, let me tell you, the script is basically a list of commands that you want to execute one after the other. So first command I want to run is I want to install the Apache web server, a command line utility called wget to get or to download stuff from web in command line. And then I have PHP. These three are going to be installed. Then I'm asking it to use wget to fetch a page index.php from my GitHub and place it, so hyphen capital P place under var www.html. That happens to be document root for Apache web server. This is from where index.php is going to be served. Then I'm asking it to enable HTTPD and service HTTPD start. What that means is, if I click on launch instance right now, as soon as the virtual machine is created, this user data will run, and I do not have to log into the virtual machine to install or configure any of these. It's already done for me through, because every time virtual machine starts, now when I'm saying not every time, I mean every time you create a new virtual machine and you are starting up, for the very first time, the user data runs and installs or works everything that you've written in the script here. Let me make a small change before I go back to advanced details. Network settings I want to enable. Do that in C. Enable, use security group. It's compulsory that you specify security group. Demo SG, and let's check in demo SG if I have enabled HTTP. So that's security group. Demo SG security group. Incoming rule, inbound. Do I have a rule defined for HTTP? I have a rule defined to allow HTTP from anywhere. This is perfect. That's it. Under advanced, we are looking at user data concept in EC2. So for this user data, let me click on launch instance. Go back to instances, refresh here to find web server, and we are going to wait till the time the web server starts running, and I should be able to see check passed. That's the public IP that I'm going to use to send a request to my web server here. So if the user data executed successfully, we should be able to see the details. Okay, still initializing. Those who are wondering what exactly is this initialization check, these are various kinds of checks that it performs, all related to your hardware, software. Is it all running good? And if it is, it will show you whether it has passed all the checks. And passing of all the checks is kind of an indication that your virtual machine is healthy and you can continue using it. I suppose we can proceed on, select the public IPv4. And open a new tab, check it out. I've only enabled HTTP. So this is another thing that I wanted to bring to your attention. So most of the time when you copy the IP address and you try to put it across, it still keeps showing that it's not yet ready. Mostly it is because that it's using HTTPS as the protocol, but our application is HTTP and not HTTPS. So there it is. That's my web server running. And you can see this page was generated by DFFE2. This is a deliberate attempt from my side to prove that it's running in this virtual machine. This virtual machine is running in US East 1C, having a private IP of 94.161. So that's my web server, right? When I'm creating the virtual machine by defining a script in the user data, I'm asking AWS to take a configuration step ahead and basically run that script for me on my behalf into the virtual machine. I am clear of logging into the virtual machine. I don't have to log into the VM and then run the script every time. So Mahendra, this it will do for one or all the virtual machines. If you've defined the details here and you specify the number of instances, like here it says only one by default. But if I'm trying to do that for 100, you can see that it says when launching more than one instance, you need to consider using EC2 auto scaling. So I'm going to talk about user data once again for when we do EC2 auto scaling. But that's exactly what user data does. It lets you define a PowerShell script for Windows and shell script for Linux, whatever you want to run as part of configuration step as soon as the virtual machines are created. Next part that I want to talk about is EC2 instance metadata. EC2 instance metadata should be disabled for where it's not being used, because it exposes a new surface, kind of not good for security, right? So you want to keep it disabled, but by default it is enabled, and by default it will show you V2. We have IMDS, instance metadata service. We have version 1 that was susceptible to some security issues, and we have version 2 which is more secure, which is token based. I'm not getting into the details of those security implications of this, but rather I'm going to talk about what's the use case of instance metadata, right? Now for this I will log into the Windows VM. Let's do that again. Let's connect RDP. That's the RDP. Asking for password, we all know. Get password, upload file, Mumbai root lab, MP root lab demo, decrypt, copy, and paste it to log into your VM. Now, let's talk about a scenario. Right now, you are looking at my management console as well as you are looking at this operating system. Imagine if I am not the cloud administrator. I do not have any cloud console. What I have with me is just the IP address, username, and password to connect to this virtual machine. Now I'm connected to the virtual machine. What I want to do is I want to see multiple details. For example, multiple details like which availability zone is it running in? What is the public IP of this virtual machine? Now you may have the answer by looking at this, but this is basically a tool that it's running called BG Info that provides you that information. Right? It fetches the information from instance metadata service that is running on the same machine. But let's not focus on this. What if in case my company has just stripped away that application that shows up these details, and then you're left with nothing, right? So imagine as if you're blank, you are not having access to the cloud related information. So what you may do, that to find out what is my IP address, I may go back to my command prompt cmd, may run the command ipconfig to find the IP address of my VM. But ipconfig is only going to show you the private IP of your virtual machine, because the public IP of the virtual machine is courtesy of AWS. It's not part of your operating system. It's basically provided by AWS for ease of operation. What's happening here? Let's see it on the blackboard. What's happening here is when you're creating a virtual machine in AWS, the private IP is an innate part of the virtual machine. So let's say the private IP is 192.168.1.12. This is innately the part of your operating system itself. So when you run the command ifconfig or ipconfig, it shows you that private IP. But the AWS public IP that we have is courtesy of AWS. Sorry about that, guys. Yeah. So the public IP that I'm talking about as said, courtesy of AWS, it's outside the scope of this virtual machine, even though when I say outside the scope of the VM, whole of this thing is running inside AWS itself, but it's just that the public IP happens to be outside the scope of the virtual machine. So, but then, Mahendra, if it is outside the scope of the virtual machine, how is it running? How am I sitting in Bangalore here be able to use, because this is a public IP, so I'm using internet to connect to the public IP, and this public IP internally has a mapping with the private IP, and this is automatically done by AWS, right? The automated mapping of the public IP, direct mapping of the public IP to private, means any kind of incoming request coming for the public IP is as it is directed to the private IP of the virtual machine. Now, this is the concept that I wanted to let you know about. Let's go back to our screen. And then why is it not visible here, Mahinder? Why is it that we can't see the public IP? As I said, outside the scope of this operating system. It's the setting or it's the kind of configuration part of the EC2 service provided by AWS to get the job done, right? So remember that uh, the public IP is directly mapped to the private IP of the VM. So what we were talking about is instance metadata service, right? So scenario is I am a Windows administrator. I do not have any idea of what my public IP is or what my region is. Which region is this operating system or this virtual machine running in? You can't do anything from here, right? Unless and until you look at that information that it's showing through BG info. And I said, if I disable that tool, you won't be able to see that as well, right? How does it work? So instance metadata service is to be enabled. It's a service that works individually for each virtual machine that you create internally. It is not accessible from outside world. It's okay, yeah. The instance metadata service runs on this IP address 254.169.254. As you can see here, this is kind of loop back the address that you're looking at. That means you need to have been logged into the operating system itself, the virtual machine, to be able to use instance metadata service. So let me go with slash latest. Amanda, where did you find latest? Here it is. I'm sorry, I'm bad with remembering all these paths and all. So I take help like this. So I say latest and then it says meta hyphen data. So latest meta hyphen data. And then under meta hyphen data, I do have host name. This is what I'm looking at. This is what I want. So when I enter that, that's my public IP. That's the public IP of this virtual machine. Now, if you try to compare that, you'll find the same address over here, right? That's instance metadata service. So if you are logged in into the operating system and you may want to find information that is normally visible only from Cloud Console, right? If you want to do that, you can use the metadata service. Now, this will only work if in case you have enabled metadata. If not, it won't. For Windows, you can use a browser if you are working with SSH or console. Then you may want to use, let me log in. If you're logged in like this, in the management console, you may want to use curl. One six nine dot 254.169.254 slash latest slash meta hyphen data, and there it is. It shows up like this. Amazon Linux also provides a utility. You can simply say EC2 hyphen metadata. This is a command that does exactly the same thing. It queries but it presents it in a more easier format for you to read and understand. So that's your instance metadata service. Very useful if you want to automate and you're running some kind of script, non-interactive one, and you need the public IP of the machine. You may want to see the key name or what security group is it using, right? You can find all that information, instance type, AMI ID from the metadata service. A very useful thing for when you are trying to automate certain tasks. Let's go back and see. So that's about launching and managing EC2 instances. Now let's focus on security and networking. Okay. Now, looking at networking portion of EC2, I said, guys, I would recommend you go ahead and watch the VPC Open Masterclass. That's definitely going to help you. I won't be able to cover as much as the depth that I've covered over there, but there are certain things I would like to mention here since we are talking about networking. VPC and subnet can be selected. We have already seen can be selected during launch of the instance. Security group as a proof of concept I wanted to show you. And another part here in networking that I want to focus upon is elastic IP address, right? So let's start with networking. As said, the virtual machine has private IP address as well as public IP address, and all of it is configurable. You can configure and you can either enable usage of public IP, you can disable it. It's all at your discretion. How do you want to create and use the virtual machine? But by default, you'll always find a public IP being enabled for a VM. Yeah. With every virtual machine that you'll connect, you'll have a primary network card that is associated. We call it network interface. This is just like any other server that you might have seen and worked with, or any other machine that you would have worked with. Every machine has a network card, and this network card here is known as Elastic Network Interface. Elastic Network Interface. That's the ENI 4A3F for Windows VM. So let me go to Network Interfaces and 4A3F, that. I give it a name. This becomes easier for me to recognize with the same name as the virtual machine. So this belongs to Windows VM. Now, if you look at the card has got details like IP address, and it's also got detail like what security group is associated with the card. Now, if I have to draw and show you, this is what we are looking at. So if you've created a virtual machine, VM will always have a primary network interface card that is associated with the VM. Let's call it elastic network interface. And it is through this elastic network interface that it gets associated with the VPC. And inside VPC, we have a subnet. So how does your virtual machine become a part of the subnet? A virtual machine has an elastic network interface, and elastic network interface is associated with the subnet. Subnet in its turn is part of the availability zone. Now, those of you are still wondering what exactly availability zone is, you may want to go back and see some previous master classes that I've done. You will be clear with this. Recorded master classes. So virtual machine is connected to, associated with a subnet and part of the subnet through the elastic network interface. And this ENI that I'm talking about, this ENI has got all types of IP addresses associated, whether public IP address, private IP address. This also has a security group associated with it. That means anything that is to get in from the subnet into the virtual machine, or anything that needs to get out, will be inspected by the security group as a firewall. And all of this is happening on ENI, Elastic Network Interface. So we do not configure in virtual machines in AWS, we do not configure IP address and other details for the network card from within the operating system. We don't do this. We don't go to the virtual machine, and I'm not going to do this. So, not part display. I'm going to system, network and internet, Ethernet. Imagine if I want to provide it a manual IP address. You do not want to do that from here. Nope. It's not to be done from the operating system, because next time when you restart the machine, you'll find that all these settings are overwritten by the configuration that you do on the card over here. Manage IP addresses, right? So that's the IP address, private and public IP provided right now. Assign new private IP address. I can assign a new private IP address if I want. If you do not write anything, it will auto assign from DHCP. But if you type something, 172.31.0.115. So 112 and 115 are going to be two IP addresses on the same ETH0 network card, right? IP aliasing that can be done. So you're doing it from here, not from within the operating system, because anything that you do here will automatically take effect in the OS, not the other way around. So that's the reason why this network card information was necessary. Going back to the instance. Focusing on this web server right now, I wanted to note down what's the IP address of this web server. Let's take it. So that's the IP address of the web server right now. And I wanted to stop and start it again to see what kind of changes will I find here. Let's make some more room. What changes do I find? So let me go to state, stop the instance. Focusing on the IP address change. I hope so this is stopped. No, it's still stopping. Stop. Now, as soon as it is stopped, I wanted you to focus on what it shows here for public IPv4 address. It's all gone. It just disappeared. As I said, till the time the virtual machine keeps running, the IP address, the public IP is going to be associated. It's a rotating IP, it's not the fixed one. So every time I reboot my virtual machine, reboot is not the exact reboot that you see here. So if you reboot, it won't affect it much because reboot is a soft restart of the virtual machine. You'll have to stop the virtual machine and start it again. And when I start it again, you'll find that the IP address is going to change. It's not going to be the same IP that we see here. Let's check it out. And do we have a new IP already? Yes. For web server, we do have a new public IP that's been granted already. You can see the change. The previous IP address was the one above. And right now the IP address that we've got starts with 54, right? So this is kind of an innate nature of public IP address. A public IP address always happens to be temporary. Till the time the virtual machine runs, the IP address is available for the configuration and other usage. As soon as you stop it, it just vanishes. And you'll be assigned a new one for whenever you start the virtual machine again. So how do I make it permanent? How do I make it a fixed static public IP? Static public IP here is known as elastic IP address. The naming differences for the same purposes. As and when we say that I want to use a public IP must always be considered as a rotating one, a temporary public IP. For when you want to speak about a static fixed public IP, you are looking at elastic IP address. Let's have a look at it. So now if I want to allot it a elastic IP address, a fixed IP address, I will have to go to elastic IP. Mind it, let me repeat that all of these IPs, whether it is elastic IP, public IP, private IP, security group, these are all associated with the network card. Right? So all these configuration settings that you're doing is on the network card. So let me go to elastic IP. I have two IP addresses. I'm not going to use them. I want to allocate one more elastic IP address. So let me click allocate from AWS Amazon's pool of IPv4 addresses. Let me click allocate. This is the one that is allocated. Let me give it a name, demo EIP, elastic IP. So this is just allocated, right? If you've allocated the IP address, and you're not using it, you will have to pay the fine for the same. Yes, that's correct. So if you've allocated, you're wasting. If you're not using it, you're wasting the resource. And for wastage, you'll have to pay additional amount. It's not going to be separately charged. It will be part of the invoice that you'll receive from AWS for EC2 section. So I'm not going to do that. I don't want to end up paying for any additional charges. So allocating is getting the IP address on request from AWS. Now I want to attach or associate this IP address. This IP address I want to associate with an instance web server which I'm running, and let it be directly mapped to the private IP address of the web server. Let's keep an eye on this simultaneously. So here is my instance Windows server, keeping it away, and I wanted you to focus on public IPv4 here. Elastic IP address shows none. And in this window, we'll associate the IP. Let's go ahead and do that. Associate IP. You'll find a change. Elastic IP address 54.209.9.240 has been associated with this instance. It's still not showing up over here. I will have to refresh it once. But if I refresh, you'll find the change. Instead of 60 as the IP address, it will show 240. And here for Elastic IP, it will start showing that this is basically an Elastic IP address. There it is. This must show up. Let me refresh the screen once. There. So it shows that the public IP of this now. Remember, public IP without EIP being shown up, if these two things do not match, that means the public IP that is showing up is temporary one, the ever-changing IP. But you see this here as well as this, you can understand that it's a non-changing static public IP associated with the web server. A good use case for this is if you are running a single server without any load balancer and you do not want the IP address of the server to change, because that is what your people in the office or your customers are using it. So you may want to allot a static public IP. Though from security point of view, if you ask me, I'm not in a favor of using a fixed IP address. A fixed IP address gives ample of time for DDoS attacks to take place. So I'm a fan of ever-changing IP addresses, and it's good from security point of view. But yeah, there are some use case scenarios where you may want to use EIP. So what do you do if you're not using it? Well, if you're not using it, it's good to go back to EIP, select the EIP, say I want to disassociate. Now, after disassociation, you want to select. So I want to do for both the IPs because this was the previous one that I was using before. And you want to release elastic IP addresses. Okay, so this cannot be. So let's go with a single one. Release. Now, when you release this, it goes back to the pool of AWS where AWS can provide this elastic IP to someone else. Rather, what we had done is if you're not associating, you just requested, it's out of their pool. Nobody can use it, and neither you are because you're not associating that with the instance. And that's what you pay penalty for, right? Okay, so let me check for this one. This is associated. Now, so guys, we move to the next part. One more demo for security, and then I'm going to go back and talk about elastic load balancer, auto scaling, storage and data management, monitoring and optimization quickly. So let's go with security group. Now for security group, everything inbound is by default disabled. All these settings that you see here, these are all done by me. I've configured it. I wanted to remove this ICMP, save rules. And what I wanted to show, I wanted to see only one, so filtered it out. What I wanted to show you is if I'm trying to ping any virtual machine from here right now, as far as security is concerned, it's secure provided we haven't made any change to the security group. So let's do that for the public IP here for the web server, keeping it side by side so that you can have a look at both of them or both of the screen. When I'm trying to ping, it says can't, request timed out. All for the reason because security group does not allow it. So here is our security group. And in security group for demo SG, the inbound rule does not say that it allows ICMP. If in case we do, so edit inbound and we add a rule for all ICMP v4 and say that all ICMP v4 packets coming from anywhere using IPv4 address. So for anywhere, it just takes the wildcard expression in networking for 0.0.0/0. And then if I click on save rules, and you can read here, it says rules with source of this allows all IP addresses to access your instance. We recommend setting the group to allow access from only the known IP addresses. But that's fine. Since this is demo, I can go ahead and save the rule. And as soon as the rule is saved and it takes effect, you will find that the instance now, I hope I'm running with the same instance. Okay. So it had a changed IP address, and that's the reason why. Let me go back. Do it for this IP. It's pinging. I'm sorry guys, I'll just go back and delete that rule, come back again and show you the proof of concept. So when the rule does not exist for ICMP, and I try to ping the IP address, as you can see, it says request timed out. And when it does, for ICMP v4 from anywhere, it starts pinging. So uh, for protecting the perimeter of each and every virtual machine that you have, you can go ahead and make changes into the security group. A more detailed explanation is provided. Apart from security group, we have second layer of defense using firewall, and that's going to be that was something that was explained in VPC. Okay, we have elastic load balancer, auto scaling, storage and data management, monitoring and optimization. I think so. I've put in a lot of things to be done with EC2 for a day. Uh, so, guys, I think so. I will stop over here and we may continue EC2 Open Masterclass the next weekend as well, wherein the focus is going to be on elastic load balancer, auto scaling. I may include the global load balancer, that is your global accelerator as well. And we'll go back and talk about storage, data management, monitoring, and optimization. So next week, that is Saturday, we'll continue with EC2, but it's going to be all about the remaining portion here. Thank you so much, and I hope you liked this. We'll meet again. Thank you, guys. Have a good day.